Hello, and welcome to week 4. In this video, I'll be extending your processing vocabulary with several new functions. We'll first take a look over transforming the grid in your sketches, then we'll explore the code blocks needed for external input, and lastly, we'll examine changing the way processing works with colors. So, let's launch processing and get coding.
Okay, so here we are in processing, and I've set up a sketch that's almost completely blank except for all of this commented code that I have set up to go over all the new functions that we're going to be covering in this video. We're going to be working with transforming the grid, working with external input, and changing to the HSB color mode. So one of the first things that I've done here in the void setup function is set up my canvas size to be 640 by 640. Now I want to introduce you to the color mode function. The color mode function is accessed by typing color mode using the camel case with the uppercase M, and then opening up and typing the color mode that you want to use. In this project, we're going to be working with the HSB color mode, which stands for hue, saturation, and brightness. So I'm going to say that the maximum value for the hue range is going to be the width of my screen, and I'll say that the saturation range is going to be my height, and I'll say that the brightness range is going to be a value between 0 and 100. So what this will allow us to do is simply pick out areas of our screen and use them to change the color. And you'll see how that works when I introduce you to mouse input a little later in this lesson. So now that we have our color mode set up to HSB, we can change our background using the HSB color mode. So now if I type 3 numbers, a number between 0 and 640 for the width, 0 and 640 for the height, and 0 and 100, I'll be combining those 3 values to pick a color. So what I'm going to do is I'm actually going to have it generate a new background color randomly from the width and from the height. And also a random one from our seed, which is 100. So I'll go like that and close that off. Now watch what happens when I press run. So it picked a nice random color based off those values. So each time I press run, it should select a new background color. Very nice. So you see now that we can select colors based off of these variables. This will allow us, like I said, to use the mouse input to override these and to drag our mouse along the canvas and to change colors that way. So now that we're working with the HSB, our colors are going to take 3 integer values instead of previously, which was 1 hexadecimal value. So I think I like the way that the setup function looks here. Let's go ahead and move along. So if we go down here, I have several functions that I want to introduce to you for transforming the grid. So before we do that, I'm going to draw just a simple rectangle in this space, and I'm going to type rect 100, 100, 100, 100. So let me show you what that looks like. There we go, we have our rectangle there. So I want to show you how you can use the push matrix and pop matrix together. The push matrix and pop matrix functions work in tandem. And the way that it works is if you think of your canvas as being a stack of cards or a stack of layers, the push matrix pushes your current canvas onto a new higher level, allowing you to translate, scale, and rotate your canvas. And after you're done with those functions, you can resume the previous matrix stack, or in this case the default, using the pop matrix call. So let me show you how that works. So now if I enable this push matrix and then also draw a new rectangle below the push matrix and also uncomment my translate code, what translate does is it specifies an amount to displace objects within the display window. It takes 2 arguments, and those are the displacement arguments of x and y. So if I wanted to redraw this rectangle but not change any of the code, I could simply paste it below the translate function and then dictate that the canvas should be moved over 200 pixels and moved down 200 pixels. So now you'll see how that works, and I'll press play. Okay, so it's given us a little error. Because we are in the active draw mode, it called upon the push matrix more than 32 times, which is a built-in limit in processing. So if we continue this code, I'll go ahead and first unlock the pop matrix, and that error should go away. Yeah, there we go. So as you see, the push matrix in active draw mode should not be called alone. You should always resume the matrix back, because what this is doing is as it iterates through the draw function, it's drawing a rectangle, pushing the matrix, translating the matrix, drawing another rectangle, resuming the matrix, and then doing that all over again. And just as a reminder, if you didn't want it to iterate through that, you would type no loop with no arguments up here. But I'm going to allow it to iterate for now, and we can choose to turn off the loop later if necessary. Okay, so next we have the scale function. The scale function increases or decreases the size of a shape by expanding and contracting the vertices. Objects always scale from their relative origin to the coordinate system. And scale values are specified as decimal percentages. For example, the function call scale at 2.0 would increase the dimension of the shape by 200%. So what I'm going to do is I'm going to go ahead and just copy this rectangle drawing function and paste it below the scale. And I'm going to uncomment this scale code. And I'm going to do exactly as I mentioned and put in 2.0 to increase the size of this rectangle by 200%. Let's take a look at what that looks like. Very good. So we see our original rectangle and our scaled rectangle. And just a reminder, this rectangle code is exactly the same with the 100s all across the board here. Okay, so next we have the rotate function. The rotate function rotates a shape the amount specified by the angle parameter. So it takes one parameter, the angle parameter, inside the argument. And angle should be specified in radians. Now radians was a little tricky to work with when I first introduced arcs. So I want to show you a way to convert degrees into radians very easily inside. So what I'm going to do is I'm going to copy this shape below this rotate function. And then I'm going to uncomment it out. So normally you would put a radians argument here, like pi or 2 pi or any number between 0 and 2 pi. But if you want to type in degrees, like if I want to rotate this 15 degrees, I can type radians, open and close brackets, and then put your degrees in here. So if I want to move this 15 degrees along the circle, then I type radians and in 15. This is the same way that we can convert a float to an integer on the fly. So let's see how that looks like. Okay, so you can see that it's actually pushed our object slightly off the canvas. You'll notice that the rotate function rotates along the axis of the upper left-hand corner of your object. So if we simply changed our scale to something less like 1.5, should stay on our canvas. And it does. Excellent. So what I've shown you here is the basic functions for transforming the grid with your shapes. Now you'll see here that when I place another rectangle along the outside of the pop matrix, it's going to maintain its same origin. And I'll draw it so that it appears over the top of our current one. So here's how it looks. There it is, appearing over the top. So once again, you push the matrix to push a new matrix stack. You translate to move the canvas. You scale to increase or decrease the relative size of the canvas. Rotate to rotate objects. And pop matrix to resume the previous default matrix. Now we'll take a short break to see how things are going with a brief quiz. So next I'm going to show you how to work with input from the mouse and keyboard in the draw function. So the mouse X and mouse Y location are stored in built-in variables called mouse X and mouse Y. And we can use those to change the color or change various functions throughout our process. So I'm going to use the mouse input to change the colors of our various shapes. So first I'm going to say stroke for this first rectangle. And now I'm defining stroke with the HSB values. So I need 3 values. So I'm going to say mouse X, mouse Y, and we'll just say 50 here. And then I'm going to do the fill and just sort of reverse these. So we'll do mouse Y, mouse X, and change this around a little bit. Okay, and then we will change it even more over here. I'm going to do this for these internal rectangles. Okay, so what you're going to see here is as we move our mouse around the canvas, these shapes and their fills are going to redraw themselves on the fly. So these are being aligned to the location of my mouse on the screen, and that is changing the color following the mouse X and mouse Y values. And you can see what those values are simply by typing a command line to your console. So I'll type print line, and I'll say mouse X is, and then type plus mouse X. So close that line. So we'll print that to our console. So you'll see that appear down here in the console area. So this is our current value here. Excellent. So we've used mouse X and we've used mouse Y. Now we have mouse pressed. Mouse press is a Boolean that you can test. And so what you can do is you can create an if statement and put mouse pressed inside and test and see if it is true or not. So let me go ahead and write one of those statements to check on the mouse pressed. So what I'm going to do is I'm going to move this up above here. And what I'm going to do is I'm going to say that this last rectangle won't be drawn unless the mouse is pressed. So here we go. I'm going to say if, open it up, and we'll type mouse pressed, and type equal equal, because that's the qualifying equal. Instead of defining something, you put one equal sign, or to test something, you put two equal signs. So I'll say mouse pressed equals equals true, and we'll type that in lowercase. So then I'll open my curly brackets, put the rectangle code inside. I'll just tab that forward and close my curly brackets. And now when we run this, it won't draw this until I click a button on my mouse. Okay, so we have our last rectangle. It's going to appear inside this first rectangle here. So if I click, there it is. And it's gone too, because after the draw iterates over itself, it erases it. So click, there it is. If I click and hold, it'll stay because it's reading mouse pressed, mouse pressed, mouse pressed the whole time, and I can let it go. So that's how you use the mouse press function. And then the key press function works almost exactly the same. So if I get rid of this here, get rid of this comment, and change this to be key pressed, this simply works by pressing any key on your keyboard. So I'll press play, and then I'm just going to tap the space bar here, and there it is. Let go, and it's gone. Tap it again. There it is, and it's gone. So that's how you work with key and mouse input in the draw section. But what you can also do is you can create input based off of mouse moved, mouse dragged, mouse released, and specific key pressed and key released. So let's explore those functions briefly, and then we will wrap up our lesson for today with the mouse and keyboard input. So let's check out the mouse moved function. The mouse moves function is called every time the mouse moves and a mouse button is not pressed. So the way this works is it's going to put something onto the screen, or it's going to validate the code inside this code block only when the mouse is moving. When the mouse is not moving, everything will stay the same. So what I'd like to do is every time the mouse moves, I want to change the background color based off of random numbers. So what I'm going to do is I'm going to say background, and then I'll just call a few random values here. So we'll say, just as we did at the top, random out of the width, random from the height, and then the last value we'll just call random out of 100. So now each time we drag the mouse, the background color should change. So let's take a look at this. This is mouse moved. There we go. There we go. This can be very intense because the frame rate is set very high. But you can see that it's redrawing the background. And you can see actually because of the push and pop matrix, the background is actually erasing what's on our grid, and then it's being redrawn. So this happens each time the mouse is moved. So now what I can do is I can show you how this same function works with the mouse dragged. So this is code that will only be called each time the mouse is clicked and subsequently dragged. So now if I press stop and run, we are changing the colors on these objects, but now we can change the color at the background with a simple click and drag. If I click and slide around, I can simply step through the different background choices here. Okay, so that's how you work with the mouse drag. That's a function that's called once every time the mouse moves and a mouse button is pressed. That's the definition of a drag. Now, next we have the mouse released. So this is a function that's called every time a mouse button is released. So here I can click, but nothing will happen. I can move and nothing will happen. But when I let go of that mouse button, I'm going to get something that changes. So I'll go in here, press stop and run. So here we go, moving around, nothing happening, clicking and dragging, nothing happening, and now I let go and boom, color changes. Click, let go, color changes. Click, let go, let go, let go, let go. So this is following my mouse button being released. Okay, so next we have the key pressed and key released. This is similar to the mouse function, but what's going to happen here is that you can decide what key is being pressed. So let me show you what I mean by that. So in the key pressed code, I can write an if statement that looks something like this. If key, and then I'll do the qualification equal sign. That's 2 equal signs. And then in single quotes, I can put the letter. So I'm going to put S, and if I want it to also read uppercase S, I'm going to put the and or logic qualifier and then type key equal equal capital S. So this is going to ensure that no, if caps lock is on, this function still works. So I'm saying if key S or key uppercase S is pressed, then you're going to open your code block. I'll paste this here, close off my code block. So now when I press S, the background color should change. Let's take a look at that. Pressed S, 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 S. Okay, so that is how you use key press and how you specify a specific key to be pressed. And then lastly, we have the key released. So if I grab this code, the background code, and here we go. This works the same way. Let's grab all this code here, paste it. So now, if I run this, when I press S, this shape appears because we have the key pressed for this shape to appear. But now when I release S, the background color will change, and I'm going to release now. Press and release, press and release. So you can have alternating functions that work once when you press the key and once when you release the key. Okay, so we've gone over a lot of new things here. We've taken a look at setting up and changing your color mode. We've taken a look at transforming the grid through several new functions, including the push and pop matrix to change your matrix and restore it. Then we looked over mouse input and keyboard input in the draw function. And then we looked over mouse input and keyboard input in their own code blocks. In the next few videos, we're going to be going over specific projects that implement all of these new functions.